So with continuity on an interval, what we want to be careful of is where those types of discontinuities pop up. So with that, we're going to use this graph down below and evaluate some function values, our limits from one side, our limits from both sides, and then we're going to talk about the discontinuities that we're seeing pop up in this graph. Okay, so function outputs, I'm looking for y-coordinates. So x equals -8, we have a hole in the graph, and then we're not defined anywhere else. So this is just going to be undefined. At x equals -5, we have a hole in the graph, but we have a coordinate defined elsewhere up at x equals 7. So that's going to be an output of 7. At x equals -3, we have a function output at that corner there, which is -8. At x equals -2, we have a jump there, but our function in terms of where it's defined is down at -6. At +2, we have a vertical asymptote, so we're undefined there. At x equals +6, we have a jump, and then we're not defined anywhere, so we're going to be undefined. Okay, limits from the left. At x equals -8, if we're approaching from the left, we're approaching +2. As we're approaching, I'm just going to go ahead across these, and as we're approaching from the right, we're also approaching 2, which means the two-sided limit is equal to 2 since those match up. When we're at x equals -5, so approaching from the left, we're approaching an output of -4. From the right, we're also approaching an output of -4, which means our two-sided limit matches up at -4. So even though we're defined elsewhere, our limits are approaching -4. At x equals -3, so as we're approaching from the left, we're getting closer to an output of -8. From the right, we're also approaching -8, which means the two-sided limit is a -8 as well. At x equals -2, so that's where we're looking at our jump right here. So from the left, we're approaching a -6. From the right, we're approaching a -2, which means our two-sided limit does not exist. At x equals +2, so that's where we have our vertical asymptote. So from the left, we're going down to -infinity. From the right, we're also going down to -infinity, so they're matching up, going to -infinity. And then at x equals 6, we have the jump. So from the left, we're approaching a +4. From the right, we're approaching a +8. And since they're not matching up, that limit for the two-sided does not exist. So let's talk about the discontinuities that we're seeing here. So I'm seeing, and what you could do is try to draw it, and as soon as you have to pick up your pen, that's going to be a discontinuity. So drawing, I would have to lift my pen at the hole right there. I would have to lift up here. I would have to lift up here. I would have to lift up here. And I would have to lift up here. So I'm seeing 1, 2, 3, 4, 5 discontinuities. One is happening at x equals -8, x equals -5, x equals -2, x equals +2, and x equals 6. It's almost like that table up above chose x values in a very specific way. Okay, so in terms of our subproperties, when we have a hole in the graph, that's where our f of a is not defined, so we'd be failing that property 1, which also makes property 3 not work. And that is called our removable discontinuity. At x equals -5, we now have f of a defined, so property 1's okay, but we're still failing property 3 because that two-sided limit is not approaching the output value because or defined elsewhere. So this is also our removable discontinuity. It's just one where we're defined at another coordinate. At x equals -2, we have our jump discontinuity. So our function's defined, but our two-sided limit does not exist. So we're failing property 2, which makes property 3 fail. And that is our jump discontinuity. At x equals 2, we do actually have the two-sided limit here, so that's defined. What we don't have is f of a is not defined, and that's going to make property 3 fail as well. So that's a little different than we saw in the previous one. That was because the infinity was operating differently on either side. But with this one, because they're matching up, it'd be a little different. It isn't all 3 properties failing, just that we don't have an f of a. All right, and then at x equals 6, we don't have f of a. Our two-sided limit does not exist, does not exist. And so that's going to make 3 fail as well. So this is all 3 properties, 2 and 3. And this is our jump discontinuity. It's just another form of it. Okay, so let's talk about intervals where we are continuous. What are the intervals where we can draw our function? So this is just asking true or false. From 2 to 6. So at 2 but not including 2, and then going up to 6 but not including 6, is that continuous? Yes, we could draw our function over that interval without picking up our pencil. From -5 to +2, so -5 but not including, I'm here, and I'm going, but then I have to pick up my pen to keep drawing. So with that, that is not continuous. And then from -2 to +2, so at -2 to +2, we're not including the +2 portion. But something I want to pay attention to is that this is including -2. So when x equals -2, we're actually down here. So right at the beginning of this, we have a jump. So even though it looks like it's continuous because of the bracket that was used, and it's saying that we're including the -2, this is going to be false. There's some ways of evaluating continuity, and we'll do even more in the next video.